Student, let's see in continuation. Specific heat capacity of a gas, right? Students, you know, when a gas is heated, its volume and pressure change or not, right? Yes or no? Its volume and pressure changes, right? If volume is increasing, then pressure may decrease, right? If pressure is increasing, then volume may decrease. Getting or no, students? So on that basis, how much heat is required? The amount of heat required to raise the temperature of 1 gram of substance through 1 degree centigrade is not fixed. Why? Because we have having pressure and volume, two other parameters, right? So on that basis, we have classified molar specific heat at constant pressure, right? Give heading molar specific heat, molar specific heat at constant pressure, at constant pressure, right, student? Molar specific heat at constant pressure, correct? So, right, it is the amount of heat required. Molar specific heat at constant pressure. It is the amount of heat required, right? It is the amount of heat required to raise the temperature of 1 mole of substance through 1 Kelvin or 1 degree centigrade, right, at constant pressure. So Cp is equal to 1 by N delta Qp by delta T. So on cross multiply, you delta Qp is equal to Ncp delta T, right? Delta Qp is the heat given to N moles of substance at a constant pressure, and delta T is the change in temperature, right? Understood? Let's see molar specific heat at constant volume. It is in the same way amount of heat required to raise the temperature of 1 mole of substance through 1 Kelvin, right? At constant volume. So that is Cp is equal to 1 by L delta Q V by dt. Delta T, delta Q V is equal to Ncv delta T. Delta Q V is the heat given to N mole of substance at constant volume, and delta T is the change in temperature, correct? Understood or not, students? So next, let's know the relation between them, right? Let's know the relation between specific heat relation, right? Cp and Cv relation between Cp and Cv. That is also known as Maer's formula, right? So give heading specific heat relation, correct? Let's know about specific heat relation. That is also known as Maer's formula, right? Let's derive that one. It is also the same way relation between Cp and Cv, right? Relation between Cp and Cv, molar specific heat at constant volume and molar specific heat at constant pressure, right? Students, Maer's formula is considered for 1 mole of ideal gas, right? Here gas is to raise temperature by delta T. We want to raise the temperature by delta T. Yes or no? And students, you know first law of thermodynamics, what it state? Ki delta Q is equal to how much? To increase the internal energy and partially in doing the work. How much heat you are giving, that increases somehow the internal energy and somehow the dW work done. And dW, you know PdV, right or not? P into delta V. You know, students? Pressure into volume, correct? Yes or no?
Yes, sir.
And if heat delta Q is absorbed at constant volume means delta V is zero, na students? That means if delta Q heat is observed, delta Q heat is observed at constant volume, then delta V is equal to how much, student? Zero, na? Correct? Yes or no? If delta V is equal to zero, then Cv is equal to how much? Delta Q by delta T whole into V. That is equal to only delta U by delta T, na students? Why? Because delta V is zero, na? So this part will not be there. Only delta Q by delta Cv is equal to what? Delta Q by delta T. Constant volume, that will be also equal to delta U by delta T. Getting or not? Because this part is zero, na? Yes or no? Students, are you getting?
Yes, sir.
So this expression you got. If in the same way we'll say delta Q is the heat absorbed at constant pressure. This is for constant volume, right? This is for constant volume. And next we took delta Q is heat absorbed, right? Delta Q is heat absorbed at constant pressure, correct? So that is Cp is equal to how much, students? dq by delta t, sorry, delta q by delta t at constant pressure P. That will be equal to delta u by delta t, correct? At constant pressure, plus P into delta V by delta T at constant pressure. Yes or no? Getting now? Getting or not, student? So that can be delta U, change in internal energy with temperature, plus P into delta V by delta T at constant pressure. Are you getting all, students? You got Cp, you got Cv, correct? And students, we can now make Cp minus Cv, correct? So see, if I'll make Cp minus Cv, then the Cp minus Cp, so this part will be cancelled or not? du by dt, du by dt. This part will be cancelled, na students? Cp minus Cv. Then only this part will be there, correct?
Yes,
That is P into delta V
yes,
by delta T will be there. P into delta V by delta T will be there at constant pressure, correct? And student, you know, for 1 mole of gas Pv is equal to nRT, na students? For 1 mole of gas, right? For 1 mole of an ideal gas. You know this equation? Pv is equal to nRT, correct? That means for 1 mole means N is equal to 1. If I'll put N is equal to 1, then Pv is equal to RT, real gas constant into temperature, right? Okay, students. Let's differentiate both sides with respect to time. Here, let's differentiate both with respect to time. That means here we got this equation. Now, differentiate. Now differentiate both sides with respect to time for constant pressure, right? For constant pressure. So that is equal to how much? That is delta PV by delta T is equal to how much? Delta RT by delta T, na students? Are you getting? Getting the students? This equation I found the derivative with respect to time. PV was there. So rate of change of BPV with dt, rate of change of RT with delta T. Getting or not, students? And this P delta V by delta T, you got how much? That means this can be written as if pressure is constant. We wrote here, na, constant pressure. So pressure will come out. Then delta V by delta T is equal to how much? R coming out delta T by delta T, na students? Are you getting my point? Yes or no? And delta V by delta T, you got how much? See here. In place of P delta V by delta T, can we put Cp minus Cv? Can we put or not? Are you getting, students? So this, in place of this, we can write Cp minus Cv and delta T cancel, that is R. Understood, student? Can you derive? Will you remember Cp minus Cv is equal to R? Yes or no? This is known as, student, Mayott's formula. This is known as what, students? Mayott's formula. Understood all?
yes, sir.
That means we'll take an example. Calculate the specific heat at a constant volume for a gas, right? और यहाँ पर constant pressure specific heat Cp is given, that is 6.85 calorie mole inverts, right here, mole inverts and Kelvin inverts, and real gas constant in 8.31 joule mole inverts Kelvin inverts, and J mechanical equivalent of heat joule per calorie inverts, right? So Cp is given, R is given, J is given, right? And you know Cp minus Cv is equal to R. If I convert into calorie mechanical equivalent, if so, I can write R by J. So we can write here Cv is equal to how much to find Cp minus R by J. So that is equal to 6.85 minus 8.31 divided by 4.18. So that is equal to how much? Approximately Cv is equal to 4.862 calorie mole inverts Kelvin inverts, correct? Yes or no, students? You got an idea about Cp, Cv and R?